All right, friends, I am recording this. I will give you guys this as well. So just want to say welcome to our first Python Basics. Um, we are going to have a total of 4 of these, and these are really going to walk through the Python Basics materials, something that we just previously talked about. My name is Will. I've been a Python instructor for going on 2 years now. I really love Python. Love the different things you can do. I've been in both web development and the data science sectors. And so there's so much versatility, and that's why we love Python. And so this is just going to be a basic introductory course to very beginning pieces of web, not necessarily web development, just the foundations of Python. What is a variable? What is a code block? How do you deal with a conditional statement, et cetera, and how we do that specifically in Python. Python is going to be the language that we use for the entire data science course. And so really Python dominates the data science sphere. There's another language called R that is also very, really popular, but Python is quickly taking over as the main language there. It just has so much flexibility compared to R, and it just has so many things. So that's what we're going to be talking about today. So today's goals, we're going to have an introduction, just did that, introduce myself. We're going to talk about Google Colab and specifically how that operates. And that's what we're going to be using for our data science course. And so get a little tiny crash course. There's a great walkthrough on the platform. So we're going to slowly hit on that. We're going to talk about what is Python, why we would use it, what are some attributes of it. Then we're going to jump in and talk about variables, declaring variables. How do we add variables? Some different things we can do with that. How Python is different than other languages when it comes to variables. And then we're going to do something we call primitive data types. And so the different data types that Python has when we are storing information in a variable. Cool. So for Google Colab, I am also always going to be referring back to the platform, just so that way you guys can see this is where some information is. If you wanted to read more in depth, it might be there, right? I might hit on something, and on the platform, it's more in depth. And so I will always be kind of just jumping back and forth at any point. If you guys have questions, especially since it's a small class today, feel free to put it in chat. I will stop at every section and answer any questions that are in chat, or if you do have something on the, I believe there's a little section that's like a reaction, and you can raise your hand there. And if you see me looking up, I have 2 monitors, one on top of the other, and I'll be able to see a hand raised. If you do have a question, feel free. These classes work a lot better when we are communicating versus, me just talking for an hour, because nobody really wants that. So we use Google Colab in our whole data science program. And there's quite a few reasons for that. One of the reasons is it's a cloud-based environment, meaning, if we're doing it on our local computer, we have to make sure we download all of the software, all of the libraries, any sort of dependency we have. And what's great is Google Colab allows you to do that on the cloud, right? It already has Python downloaded. It already has all the tools and libraries that we need downloaded, so we can just have access to that. The great thing about that is even if our computer is a little bit weaker when it comes to RAM or processing power, because everything is getting processed on the cloud, right? Google's computer is processing that, and we'll see how in just a bit. Because it's doing that, it doesn't necessarily matter how effective our computer is at processing, because Google's the one who's doing all the heavy work. And so if you wanted to dive into Google Colab, it's your first ever one. We're going to look a little bit on how you would start a new file. And then from there, this is a great walkthrough for starting a new one, how to create a new notebook, et cetera, et cetera. So one thing you need to have if you have Google Colab, and for these classes, you're going to have this anyways, you will have to have a Google account, whether that's your personal account, or if you wanted to create just a specific, benjamin.codingdojo@gmail.com, and you wanted that specifically for this class, you're absolutely welcome to do that, but you will need a Google account. And so once you do that, you can go to your drive, right? So you click this guy, it sends you to your drive, and I'm currently in a folder called Python Basics. Now, my encouragement is in your drive, I would create a folder for each different stack that we're doing. And what a stack is basically a block of learning, right? So this is our Python Basics pre-coursework. Then you guys are going to hop in 2 weeks to our fundamentals stack, right? It's going to be 4 weeks of fundamentals. I will actually be your instructor. 4 weeks of fundamentals. Then we're going to move into moderate machine learning, then advanced machine learning. And if you guys are doing the 16-week, then you'll move into data enrichment. And so really that's 4 different stacks. So my encouragement is do something like this. That way you can keep everything together and you can refer back and forth to it. Now, if we wanted to create a Google Colab actual file, all we have to do once we create our Google account, we just right click here. And right here, you'll see that you don't necessarily see it. But if you click this more, then there will be Google Collaboratory. Now, if you don't initially see it, you can click this connect more apps and search for it. And then you'll have to download it and basically give it availability on your Google account. But then once you do that, it'll show up just like this. You click it and here we are. This is a brand new Google Colab file where we can have our name. Right here, it just says untitled, but this is a Python notebook. That's what this IPYNB stands for. And then here I can start doing a whole bunch of things. I can start processing. I can start doing any sort of data science stuff. This exact thing was built on exactly this file in this format. Any questions on how to really start a new file here with Google Colab?
No, I think I just got it installed now on my drive. So
Awesome.
The only question I have is that the file you put in the chat, I just requested access so I could follow along on my computer.
Okay. Me. Sorry about that. Let me change that right now. Cool. So now if you click on that link again, you should have access to that and it should be okay. Cool. So moving forward, again, what I was talking about is Google takes on all the processing power. So right here on this file, you can see this RAM and disk. Basically, this is some server in the cloud somewhere that is running our material, right? We are using some computer somewhere that Google is providing for us to run this. So when we do get to the more intensive machine learning stuff, it can get a little bit slower because you're eating up RAM or you're doing something like that. But it's just a cool little tool that you don't have to download anything. It's just sort of a out of the box plug and play, which is great. One thing you can also note, if you can see it, it says connected to Python 3 Google Compute Engine backend. That means it is already downloaded with Python. Again, if you wanted to do this locally, right? If you wanted to use even something like a VS Code or something, you do have to download Python 3 specifically, but this already comes out of the box with Python 3. So it's like, we don't have to build anything. We can just go. Cool. So what is Python? Well, Python, I've said it a lot, right? But it's a programming language that was created in 1991 by this guy named Guido van Rossum. And what is really just the driver of Python is it's super versatile, right? It is in web development. It is in IoT, which means Internet of Things. It is in data science, as we obviously see here. And so because it's so versatile, it is quickly, and has just been known as one of the top languages to learn. There's a little bit of data right here. This place called Stack Overflow, which answers a lot of questions, yeah, it's basically like a developer's place to like ask a question. Does a survey every year and talks about basically what are the prime languages that people are asking questions on, prime languages that people need help with, and what developers actually write in. And as you can see, Python is number 3 on the list. The 2 before that are JavaScript and HTML. That's basically the entire web, right? Any web page that you're interacting with has to have some sort of CSS, HTML, and JavaScript. So it makes sense, right? Just because sheer usage of the internet. But from an actual language perspective, Python is number 3 right here. But it is a huge language that spreads through multiple spheres of technology, which is really cool. Some of the attributes that make it really popular is number 1, it's readability. So it's really close to English when it comes to like punctuation, and it helps promote consistent format. And so there's quite a few other languages that are a little bit more complicated, like a Java or a C++, but Python really is sort of like you're speaking English. Again, it has libraries, which is huge, right? A library is basically a list of code bits and different pieces of code that people have already built that you can go out of the box and use. That way you don't have to rewrite and kind of do all of this code. There's libraries for machine learning, which we're going to use a ton of. There's libraries for plotting stuff, right? I don't have to write the code to teach the computer how to plot something. I can just pull in a library, follow its format, and then all of a sudden I can plot and do a bunch of really, really cool things. So Python has tons of libraries that really, really make it a powerful language. There's a great community. Again, tons of people are using Python. So if you have a question, it's really common to find an answer, which is huge. In the community, people want to help. People want to continue to grow. And Python's continuing to grow in different spheres, which is just really cool. It does have scope, again, talking about the flexibility of data analytics to machine learning. You can use Pygame to create games. You can do web applications, create APIs, so many things that you can do. And Python's known as sort of one of the easiest languages to pick up. Now we are going to be using Python, primarily. That's what we're going to be using. And there's different ways to use it. And so from the simplicity standpoint, that's a little bit more back-end web development is this idea of simplicity, but it still is a really, really powerful and simple tool to use versus an R. Cool. Any questions on Python? Cool. So whenever we are dealing with data and we're dealing with code or we're dealing with any sort of programming language, there's a really common tool that we have, and they're called a variable, right? And you guys are absolutely aware of that, I'm sure. And that is just basically a variable gives us the ability to store some sort of data, whether it's a name, whether it's a number, whether it's what I had for lunch, right? I can store a ton of stuff within a variable. And in Python, there's certain variable declaration types, right? If you've seen things like JavaScript or you've seen things like R, right? Some of these are statically typed, meaning that you have to declare the data type before you even say 3. But one thing that is great is that Python doesn't make you declare anything. It's super easy. I can just say A and then put the number 3. And Python is what we call an interpreted language. Means that as Python reads this, it interprets this is the type of number, right? Or if I were to say something like this, where I would say name, and we're going to get to what this is in a second, I don't have to say that this is a string, right? Python's just going to read this and it's going to make a variable called name. It's going to store the information and it's going to say name's type is a string. That's what we mean by an interpretive language. So as it's running, it's interpreting, and you don't have to declare any of that, which is really, really neat. Now, whenever we come to this, variables can actually refer to other variables in its declaration. So right here, I've got some code. Let me just, is that easier to read? Right here, I've got some code where it's x equals 3, right? And then I'm saying y equals 3 plus x. Now, obviously, looking at that, we're all smart. We can say that y is going to be equal to 6, but just knowing that I can refer to a variable while I'm declaring another variable is really, really huge. Now, one thing to note. So let's run this. And the way we would run this, you just press this play button. Okay, it ran. There's no errors, but I can't see anything, right? Okay, so it ran. It didn't give me an error, but nothing happened. And so Python has a list of built-in functions that you can use. And we're going to talk more about functions / methods later on in this basics course. But it can do that to allow us to do simple things, right? It's already built in there. And let's say I did want to see what is the value of y, or what is the value of x. Python, the way we would do that is we would say print. So this print piece, what it is it is a built-in method that takes in what we call an argument. And so it's saying, well, what do you want me to print? Here, I want it to print x, and we know x's value is 3, so it should give me the number 3. Now, if I wanted it to print y, let's see what happens. Cool, it gave me the number 6. What happens here is when I run this print y, it's going to go and refer back to when y was declared. And it's going to say, okay, y equals 3 plus x. And when it gets here, it's going to go back up to x, where x was declared, and say, what is its value? So what it is really seeing, what it turns into is y equals 3 plus 3, right? Because this is what x equals. If x equals 4, then here would be 4. So I can refer to variables as long as they're already declared. If I were to say something like this, you can see that it says z is not defined. Now the issue is yes, Python is flexible, it is malleable, but it reads top to bottom. So it says, okay, I know what x is. Okay, y, I can refer to x, but although z is below it, it hasn't gotten there yet, so it hasn't stored that information. So this idea of 3 plus x plus z, it's saying I don't know what z is because I first have to finish this line before I can come here, and that last line has my information. So if I wanted to do that, I can from here. Now, because z has been declared, I can refer to z and then it can actually print. I run this because I've altered this. I want to make sure I run that. Then I come here and I run this, and now it says 11. Any questions on variables? Any questions on this information? Anything to note? Is this pretty simple? Simplistic?
Yeah, so far. I don't remember, but can you like delete variables in Python and then basically, oh, I don't know what that is when it runs the code.
What do you mean by delete Python?
So let's say you have a variable z, but then you discard the variable so it's no longer in the program. Because can Python do that?
Do you mean just like not? I
Discard
guess
it
what
so
would
it's
be
no
a-
longer in memory, so it doesn't know what z is anymore?
Oh, great question. Not that I know of. Because it doesn't necessarily, you're talking about like garbage collection, and Python automatically handles that. Is that what you're talking about?
Sometimes, yeah. I think that might be my question.
Yeah.
Yeah, I have never dealt with garbage collection, so.
Yeah, great question. Let's see. I'll look more into that. That's a great question. And we can talk about that on Thursday, because I've never dealt with that. Because unless the only reason with that is because if I don't need it, I just wouldn't refer to it. And because memory is not, unless you're building like an IoT, maybe that would be an issue. But for this, it would just show like, oh, this isn't used. And then you could actually just delete it from there. Or you would put it within a function. So that's a really great question. Now, one thing to note is for variables, they are what we call mutable. Now, Python has mutable variables. What that means is once I declare it, I can still change it. So here I say x equals 4. If I wanted to change that value to where x equals 5, then I were to say z equals 4. Right, I've declared z, I declare x, then I declare x again. Because that happens, okay, I've run it. Now it should go up by 1 to 12. Right here, I declare x, and then I redeclare, I change the value of this variable. In Python, we don't necessarily have this idea of, like in JavaScript, you've got var and const, or let and const, that sort of declares if one's mutable or immutable is the other version, the other word. Python doesn't necessarily have that, but there is a really common naming convention, if you see this out in the wild, to where I've got, let's say my name is a Python, is a variable, right? In Python, this is just a normal variable, right? I've declared my name, all good. Now, if I were to say something like this, if you see this, where it is in all caps, that is the Python developer trying to tell you This should not change. This should be immutable. Don't change this value. It should stay constant. So if you do see something that is in all caps, just know that that is the developer trying to tell you that this value should not change. It is, it should be immutable. Python just doesn't have a way to make something immutable. It's just from a variable perspective. Cool. There's going to be a ton of built-in functions, and we're going to look at some even today where we're talking about strings. So there's going to be a ton of that stuff that we will start adding on to. And just know that we can eventually, it's called chaining methods or chaining. These are methods. Chaining them, meaning we add on top of one another, but we'll get there as well. Any questions on variables and variable declaration? Cool. So whenever we declare a variable, what Python does is it reads it and it decides what type of value that is, right? We've said that we don't have to declare it. Like I don't have to say this is technically an int, right? It's an integer because it's a number. I don't have to say that, or I don't have to declare that it's a string or Boolean. It just interprets and decides what it is. So whatever its options for deciding what it is. Now, if I go to the Learn platform, there is a great walkthrough of data types. Now we're really going to focus on the primitive types today. These guys, these are the base types. And then next time we'll talk more about the composite types and what that looks like, which are tuples and lists. And that's where we have, these are out of the box, factory made, immutable, right? You can't modify them, but lists are mutable. Just wanted you to be aware of those vocabulary words of immutable and mutable. But if we're looking at these data types, there's really three ones that all variables are going to rely on or fall into. First one is going to be strings, Booleans, and numbers. So if we're looking at this, I think I went numbers first. When a variable is declared, it can be one of three types of numbers. First one is going to be called an integer or int. And that is going to be our whole number. So if I just have the number 3, okay, that is going to be a whole number. That is an int. The second type is going to be a floating number, and that's going to be basically our decimals. So it's going to be called a float. So if I am working with money, or if I am working with like exact numbers and I have a decimal, then that type of variable declaration is going to be known as a float. And then last one is a complex number. Now we're not going to deal with complex numbers, but I did want to give you this tool. If you were interested in looking at complex numbers, here's a great sort of read through of complex numbers and how that would operate here. We don't necessarily need that for this course and to have any sort of understanding, because what we're going to be dealing with are going to be integers and floats. Complex numbers are sort of made for like a more scientific, like special cases. But what we're really going to deal with is just integers and floats. Cool. So when I declare a variable, let's say I were to declare a variable of y at 5 and z equals 5 plus y, which we've already seen that we can do. Well, when that happens and I run this, I'm wanting to print our type z. Type is another built-in method from Python that gives us the type of that variable, right? In this case is z. And you can see that this is an int because it's an integer. It's two whole numbers adding together. Now, what if I were to change that to 5.0? Now, this is a float, right? Because it's a decimal, and this is an integer. When that happens, if I were to run this again, you can see that this changes to float. The reason for that is because y needs these extra values, this 0.0. And so what Python will automatically do when it comes to int and float is it will automatically just change and make the entire type a float. Does that make sense? It basically applies this to be, it does something like this, where it does z equals, it sort of changes this to 5 plus 0 plus 5.0. So this automatically can change. Now notice that this is the class of float. And again, we're going to talk about classes later on next week, but just start knowing that these different types are classes. And each class has something called a method or a list of methods associated to that, which we'll see for strings here in just a bit. Any questions on numbers? Ashley, any questions?
Yeah, I just
Oh,
had a
looks like
question
you.
on the
Yeah.
complex numbers. I know you're not going over them, but you did
Yeah.
talk about their use of like science stuff, because I'm trying to do data science and my background.
Sure.
So would I be seeing that more often?
No, I'm talking about like different things like imaginary numbers and representatives, like
Oh,
those sort of things. No, for data science, you're going to take either floats or integers and we'll use those to make our predictions or plot our graphs or something of that nature. This is more like imaginary numbers, really, really, really high level math that
okay.
has nothing to do with predictive modeling or anything like that.
Yeah, I used imaginary numbers and complex numbers in quantum field theory. So yeah, that's way out there.
I've used it,
Yeah.
I've imaginary numbers before. I don't use them now, which I'm very thankful for. So
Yeah. Absolutely. No, we wouldn't. If we needed those, I would obviously go over those. Absolutely not. You don't need these for the entire course. We're just dealing with floats and integers.
okay, great.
Yeah. Great question. Okay, so the first data type we talked about was numbers. The next one is a Boolean, and this is going to be your easiest data type. And it's basically a data type that only equates to true or false, right? So here's an example of is hungry is a variable, and it is true, right? I'm always hungry. I love eating, or has freckles. That would also be true, but for the sense of this, we put it as false. Now notice true and false, we're going to use Booleans a lot, especially when we come to conditional statements. But true and false, it's just one or the other, right? There is no middle ground. It is either true or it is either false. And just notice that there is a capital T and a capital F. If you were to declare this and then put true with a lowercase t, instantly it doesn't know what's going on, right? Because Python is set to, it must have a capital T or capital F. Now we can make, when we have some sort of comparisons, we can make comparisons. And what those comparisons do is they equate into a Boolean. I'll show you an example. This is going off the cuff. If I say is same, or actually, sorry, 5 equals 5. I want to print. So if I print 5 equals 5, let's see what happens. Here it says true, right? What this is this is a comparison operator, right? It's basically saying, does 5 equal 5? Okay, well, it does, so therefore it's true, right? And so what you can see is Booleans, if I have some sort of comparison, which again, we're going to get into the conditionals. If I have those, it equates into a Boolean, either true or false. So if I were to say something like 5 equals 7, right? We know that that's not true. And so it gives me false. And this is going to come really, really in handy when we deal with, let's say I want to sort, or I only want to get data rows that have people that are greater than the age of 18, right? Because I can't use any sort of minors data, right? Well, this is going to, under the hood, we're going to put some sort of condition in there. And then all the ones that give me a false there that no, this person is not greater than 18, I can do something with, right? And so it all equates into a Boolean, which is just true or false. And I can do something with it. So I can say like, if false, do something with that. Don't delete the data, or if true, then I want to go ahead and plot that. Make sense? Cool. All right. Any questions on Booleans? We're pretty ahead of schedule. That's okay.
Just one, it's about like and or. Is Python a language that spells them out like A and D, or does it use symbols?
It spells it out, which we're going to go through when we go to the conditionals. Well, there's a great table right here that does that, but it spells them out and or not. And then you can do or there's other operators. So this is like not equal to or is equal to, which are basically just flips of each other. Cool. All right. And so I saved this one for last because it is sort of the biggest and something you're going to deal with all of the time. And that's strings. And a string is just any sequence of characters, whether they are letters or numbers or symbols, any of those enclosed in either a single or a double quote. Now, just know that Python doesn't care whether it's a single or a double quote. So here I've got name equals in. If I run this, it's okay. Name equals will. You can note that this one has double quotes. This one has single quotes. Can you guys think of any reason why double quotes would be more preferred over single quotes? Any just normal thought?
Apostrophes?
Because it looks like somebody's talking. I don't know.
No, great question. Yeah, maybe. Let's think about this. Let's say I wanted to create a band name. Notice whenever I do create these variables in Python, we use something called snake case, meaning that we put an underscore and that's what separates each word. We never can have we don't want to have a space there. We don't want that will break a bunch of stuff. So anytime you're dealing with Python, if you have multiple words in just a declaration, not in like a string or anything, but in a declaration or a file name, you want to just do it. It's called snake case where we have, which makes sense. Python snake, where you have an underscore that separates each word. But let's say I want band name and it was called Will's Blue Pen, right? That is my band name. Well, if I'm using single quotes, right? Okay, I've used single quotes, but you can see that because I have this apostrophe, what Python will do is it will treat this as, okay, this is my string. And then instantly the rest of this, it says, I have no idea what this is because, this has already been closed. And so I really like to lean on double quotes because if I did want to do something like this, oops. If I did have a sentence that had an apostrophe, as long as I have a double quote, I'm good to go. If not, you have to do like an escape character and it gets sort of confusing. But this is just a way that you can, if my sentence ever has an apostrophe, double quote will not get confused there. Cool. So now let's say, my band name is Will's Blue Pen. Cool. Notice in a string, you can have spaces. That's fully okay, right? Just in variable declaration, a variable like names or any sort of function. And we'll see a function. There is, different spots where you will have a space, but just from a naming perspective, you want to have it as a snake case. Now, let's say that I wanted to add two strings together in the same way that we added two numbers together, right? Well, if I want to do that, it's called concatenation or concatenating. And that's just adding two strings together. There's some really basic ways that we can do that. Here, I've just got it where I add a comma. So if I am printing, my name is comma, and then I give a variable, well, I can do that, right? It prints, my name is Will. Cool. Then if I wanted to use the plus sign, I can also do that. This plus sign is just saying, all right, it's this string plus the value of whatever this variable is. So if I run this, it says my name is Will. Okay, this is a little bit of a sneaky difference, but can anybody see the difference and maybe why I would want to use one over the other? There's one little piece
Is
that
it
can
the
make one.
plus and you do an integer or a float? It's gonna be like, can't compute.
So that would happen with both of them. But that's a great point. We'll get to that in just a second. Anything else?
I know the comma automatically adds the space to the name.
There it is.
Oh.
That's exactly it, right? If way to go, you got eagle eyes. You did those I Spy books back in the day. If I don't have this space, and this is where a lot of people mess up. If I don't have that space, it's
for a couple minutes. I'll be right back.
Yeah.
Though.
No problem. If I don't have that space, it's going to automatically not put a space there with this concatenation. So by using the plus sign, I make myself have to use that space, which, if you're writing hundreds of lines of code, that can get really confusing really fast. So there is, doing the comma is an easier way to do that. Let's see what happens if I did this. But like you said, let's say 1 was a number. So instead of the string, there's number 7. Let's see what happens. Oh, gives me a type error. And what's great about Google Colab is if you have an error, not only will it give you an error, it'll give you where the error occurred, and it will tell you basically why that error happened. So here is a type error. We saw that we can figure out a type, and it says can only concatenate string, not int to string. And so I have 2 options. Either I can go and make sure, okay, is this right? But let's say my name is 7, right? Just like Elon Musk's child, right? What I can do is I can say str, and this is called typecasting. So what I'm saying is the value of name I want to make a string. Now I can add 2 strings together, and it says my name is 7.
Wouldn't it just be easier to turn the variable into a string with double quotations in the first place?
Yeah, you could. But let's say it was like a randomly generated number. Yeah, you could do that.
Oh, so like say if we have our variable and we have total integers, but they're being used in like a mathematical way, so they have to have that type. So doing this, we'll say, oh, you just want to do it for this instance, right?
Yeah, what will happen a lot. There's a great example of this would be when we get information from a form. So let's say we are tasked with we get a bunch of data from our company, right? It's not cleaned. We're going to learn here in a couple of weeks that data cleaning is like what we do the most of, because we're going to get bad data. Let's say a bunch of users submit on Facebook and they give you your first name, your last name, your age, bunch of data. Well, typically from a web development standpoint, when we get information from a form, depends on the language, but that can come as a certain type. So maybe it's number of kids they have. Maybe that's one of the questions we have. And they have to put 0 to, X amount of kids. Well, when I get that data, it might actually come over as a string. So what I'll do is every time I'm referring to that, maybe I want to make that, let's say another one. None of kids. So answer form answer. Right? If that's happening, maybe I want num of kids to be a int version of form answer, because I'm going to do something with that information, but I need it to be a number in order for me to do that process. So if I were to then say print type of kids, and I run this, I might get information from a form and it might come over as a string, but I can, let's say I wanted to add it to a total number, let's say up here, somewhere else in my sum of kids equals 8. I declare, let's say I just have this running variable that keeps a total of all the kids in this example. Well, if that happens, maybe I want this to, I want to print. Give me 1 second. Well, then what I would want to do is if I wanted to add this value to my sum plus, because it's a number, I can do that. The int version of my form answer. So now if my sum is 8, form answer, somebody put in 3. If I run this, I should get an error.
Sum of kids in the.
You said sum of
Not
kids.
enough kids.
Shouldn't it be sum of kids, not sum?
Yeah. In your print
Oh yeah,
statement.
sorry about that. Great catch. Yeah, so now if I were to do that, now I get 11, right? I got some information. The way it came over was a string. I need to go ahead and cast that as an int. So that way I can do some sort of operation, like add them to my total list.
So I get that. So now that you didn't print and you changed the type of the variable, is that now change in Python? Or if I type something else, form answer, is still going to be a string, or is it now an integer?
Nope, it's just in this one case,
In that, okay.
it changes. So if I were to, let's look at that.
So only if you made it like another definition and you said
Yeah,
it.
if you declared it, or there's going to get to a point where we can, when we actually get data over, we'll be up, it's a little bit too advanced now. When we get data over, we're going to be able to change the type of the column. So if all of them are strings, we're going to say, okay, I want all of these to be like when I'm cleaning my data, the type of all the values in this column need to be an int. I can do that. But for basically what we're doing, that's not applicable. But yeah, we're going to get to a point where we can do that and we can just change it over totally. But now you can see, it changes it for here because I declare it. But then whenever after I go and get the type, it still says string. Great questions though, guys. Okay, so that's two ways to concatenate strings. But then when Python 3.6 came out, it gave us something called string interpolation. And this is really the way that I would say if you were going to refer to any variables within a string, this is the way to do it. And it's going to be called our F string. And so the way you do it is, let's say you have some variables that you're referring to in some way. All you have to do is when in your print, before you are printing the string you want to print, you just put this F here. And what this F does is it tells, basically it tells the language, hey, I'm gonna insert some variable values, and then you just reference those wherever I say, right? And so here is a string that says my name is first name, last name, and I am age years old. And so the issue we saw was we had to deal with spacing here, right? This way I can just build in the exact formatting I want. So let's think about like whenever I send a bunch of blanket emails, it might say, hey, so-and-so, welcome to Python Basics, right? And it's inserting your name or somebody's name there, or hey, Will, don't forget to sign up for blank, right? And it's inserting some sort of value. This is a way that you can do that. So now if I run this, you can see that it inserted values here and the spacing is correct and the punctuation is correct. So this is my favorite way to do it. The other way you could do it is by using a dot format. And I wanted to show you this because the first homework assignment of Hello World asks you to do it in both ways. It asks you to do it in the dot format version. So yeah, so with dot format and with an F string. So I wanted to make sure that I showed you both. Dot formats is just a little bit different to where it's a little bit more heavy. So here we've got print. And then what we do is we refer and say, this is going to be a variable where all of these curly brackets are. But it reads left to right. And so this first curly bracket is associated to the first variable passed. The second curly bracket is associated to the second variable passed, and so on and so forth. So let's say I had 100 of those, it would start from left to right, and then it would do that. So the issue is if my order of my variables, if these are out of order by any way, if I get a little bit confused, if I have a larger string, you can see how this could be a little bit confusing. If I have 10 of these or 12 of these, and then I'm going and I'm like, okay, wait, which one is associated with which? That's why I personally like this F string, but this is another way you could do it to where you just refer to these curly brackets and then whichever, whatever order you have them here on this dot format, then it pushes those in and bleeds those in. Any questions on that? Pretty simple. Any questions on anything I've talked about? Cool. Well, just wanted to a little bit go over and just give you a little bit of a vision for your first assignment for Python Basics. This is going to be your Hello World. It's things we just talked about. So you should, I feel confident that you guys will be able to do this. You're going to create a Google Colab file called, and we're going to call it hello world.ipynb, right? And then make sure you have your underscore. So that way you can do it in snake case. But all you're going to do is the first one is you are going to print hello world. Then you're going to put your name or some sort of variable, right? So that way it says hello and then your name. You can put a number and you're going to have to figure out, we talked a little bit about typecasting. That's changing the type of a variable value here. And then the last part is using the dot format dot f string. And then what you'll do is you'll click file. So once you're done and it's run, you'll click file, you'll download it, and then you will just upload the notebook file right here. Just drag and drop, or you can add a link if you wanted to put it on GitHub or something. Cool. One thing to note, the way that Google Colab works, again, is you see these green little checks. That means I've run this cell. So if I am referring to a cell that does not have that green, it's going to say, I don't know what that is. So please just know that if that's the case, like if this were to be, if I just put Harry Potter here, but then I would create another one that says print, because I haven't run that file, it doesn't know what that is, right? It says Harry Potter's not defined, but once I do run this, now if I print Harry Potter, it gives me number 7. So just be aware of that. If you guys are dealing with, creating variables and then trying to print on the next one, if it doesn't have this green check mark, that means it hasn't run, and that might be a source of your errors. Cool. Any other questions, my friends? That's all I have for today.
No.
On Thursday, we're going to go into, composite types, and then we're going to deal with conditionals and loops. And so that's really where it starts picking up. So I would encourage you guys, take a look at this. You don't have to know it all coming in, but take a look at it. That way, as I'm going, you have some questions and can deal with that. Benjamin, did you have a question? Sorry.
No, I was going to say I had no further questions right now. So.
Okay, awesome. Ashley, you doing all right?
I have questions about the rest of the basics, because I already finished that part of the boot camp. So
Oh, okay.
about them, though.
You have questions on this stuff?
Yeah.
Okay, let me stop recording, and I'm happy to stay on and talk through that with you. All right, friends. Well, thanks. I'm going to end the recording.